Functions in Python. Functions. So what are functions, right? So function is a group of statements performing a certain task. For example, let's say I have this group of statements. This group of statements performs a certain task. For example, let's say finding or checking whether the number is prime or not. That is a task. Another task may be finding the GCD of two numbers, right? So this group performs certain task, right? So we name that group, right? We name that group, right? And thus we can call this set of statements as a function with this name, right? Now, why do we require function? Right? Let's say you have this big program, maybe hundreds of lines or thousands of lines, right? This big program. Now, when we write this big program, of course, different parts of this program might be performing different tasks. Now, it becomes really tedious or cumbersome for us to identify or to remember or to memorize which part of this program is performing what task, right? For example, definitely this set of statements may be performing one task. This set of statement may be performing another task. It's rare that all of these 100 or 1000 statements are performing one task, right? So it is possible, or it may be the case that different parts of this program, different sets of this sets in the sets of statements in the program are performing different tasks. So the idea is, if you write a program in one single go, or as all these statements together, it is difficult to manage this program, to memorize what portion is performing what task. So the idea is we divide, or we convert, or we make the chunks of the statements as modules, right? For example, this is one module, this set of statement is one module which is performing task 1, let's say, right? This set of statements in another module, or another this chunk is performing another task, right? So we name this set of statements, or we name this chunk as function 1, we name this chunk as function 2, so on and so forth. So we convert the big program into smaller modules, and each module is performing a different task, right? And each module is called as one function, right? So that is one reason, right? So it helps us to divide our program into modules, right, or chunks, right, which makes the program more manageable, readable, right? So then there is another reason, right? So what is the other reason, right? Let's say you have this program, again a program, right? And let's say this is a set of statement performing certain task, let's say some task, right? And let's say we are repeating this task, let's say 100 times in our program. The same task we are performing 100 times, right? So what will we do? We'll write these three statements 100 times. That means 100 into 300 lines of code we are writing for performing this task, right? So what I'm saying, we are performing this task, right? And for performing this task, we are writing, let's say, this 3 lines of code, right? 3 lines of code, and this task is repeated 100 times. So we'll be repeating these 3 lines 100 times, right? Now, can we avoid that? How can we avoid that? Writing these 3 lines once, right? And whenever I need to perform this task, let's say here I need to perform this task. So writing these 3 lines only once, and whenever I need to perform that task, just give a call to those 3 lines, right? With one line, I can give call to those 3 lines, right? That means I am writing once and reusing those lines again and again, right? So that is called as code reusability. Which is possible with functions. Functions allows me to do that. Write the set of lines only once and give call to those set of lines as many times as you want. So there are two functions, there are two main usage of function. What are those? The first is modular. It makes the program modular and manageable, organizable, right? The second is code reusability, right? So these are the two uses of function, right? The next question is, how do we write functions then in Python? How do we write functions in Python? How do we write functions in Python, right? Now, before writing a function, before looking at the syntax of functions in Python, let's see we wrote the function, and how do we call those functions, right? And what is the dialogue between caller and callee, right? So we'll write a function here, function for addition, function add, addition of two numbers. This is a very simple function which performs addition of two numbers. So writing, we wrote this function here, let's say, right? And in order to execute this function, we must give a call to a function, right? So we must give a call to a function. So this is a call, right? Call, and this is definition, function definition, right? So we are giving call to this add function from here. Now let's try to understand the dialogue between caller. This is a caller of the function, and this is a callee. Function is a callee, right? Function is a callee, and this is a caller, right? So what is the dialogue? So this caller tells tells to this add, take two numbers, because this add will add two numbers. Take two numbers, right? So it will pass two numbers, let's say 10 and 20, right? Add those, and tell me the result. Right? So this is what the caller is expecting this function add to do, right? So this caller is giving two numbers, throwing two numbers at this callee, right? At this function. Now when this caller is throwing two numbers at this add must store these two numbers in some location. So for storing these two numbers, this add function will require variables. Variables is nothing but location, or variables gives us memory to store data. So that means this add function will require the variables equal to the number of values passed from here. From here two values are getting passed, 10 and 20. So this add will require two variables, right? Right? And these two variables are called as parameters, right? Parameters required by this add, right? So with two parameters, this add will store these two values passed, right? Then this add will perform the task which this add is expected or supposed to do, that is adding those two variables or values, right? Adding. And then after doing this addition, after doing this computation, this add has to return the result back to the caller, right? So return the result, right? So that is the dialogue between this caller, which is a call to the function, and callee, which is nothing but a function. Now let's write this. Here is how we write functions in Python. A keyword def is used, def, and name of the function is add, and as we saw, this add will require two parameters to hold two values passed to this add. The first parameter, let's call it as A, the second parameter is B, and this colon, we need to put the colon at the end of this line, right? And then here we need to write the body, right? So let's say we say here C is equal to A plus B, right? And then we'll simply say return C, right? So we added these A and B and stored that result in a variable. This is called as local variable. We'll see what is local and global later. So we stored this result of addition in C, and then we are returning that result to the caller. By using this return keyword, we'll be returning the result. Now here is this call to this add, right? Let's say we are in our Python program, x is equal to add, let's say 20, 10. So this is my call, right? How the compiler understands whether it's a call or it's a definition, right? So the name of the function, and then opening and closing bracket, right? And then no colon, right? No colon like here, The colon means it's a definition, the function definition starting. Only round brackets, opening closing round bracket, that means it's a call. Name of the function, opening closing round brackets containing the values, right? So this is a call to this add function. So we are passing this 20 gets stored in A and 10 gets stored in B, right? So now A is holding 20, B is holding 10. So 20 plus 10 is 30, 30 is assigned to C, and that C, the value of C is getting written here, and that C will be replacing this line, this call. C's value is 30. So we are assigning 30 to X, and then we can say print X. So 30 gets printed. So that is how a function executes, right? So what I said, how the function executes, we have a function here, right, and then we have a call here, right? This is a normal execution of the program, right? As soon as the compiler encounters a call to function, the compiler goes to wherever the function is and it executes that function, right? And after finishing that function, compiler goes back to the statement next to this call, right? So that is how the function executes in Python. Okay, so now let's try to understand this with examples, right? So this is the syntax of the function, right? Def keyword, name of the function, right? Name of the function, right? And then the parameters that function accept, right? Now what is this doc string, right? This doc string is optional, right? If you want, you can write it. If you don't want, you can skip this. But what it does, it tells actually what this function is doing, right? It is not executed. This is not executed by the compiler. It is there like a comment just to tell what this function is doing, right? Here we write what this function is doing, right? And then these statements. Again, return is also optional. If you want, you may return. If you don't want, you may not return, right? Okay. So here is a simple example of the function. Let's see what is that example. So def, then print name is the name of the function, and this function accepts one parameter, then colon, right? And this is a doc string, right? What that doc string tells, it tells what is this function doing. This function prints the name, right? And then this is the statement, only statement inside this function. So print hello, this is concatenation. We are concatenating this string with this string hello. What is this? This is the parameter which is passed here, name, right? We are converting that parameter into string so that we can concatenate that string with this hello, right? Sometimes it may happen that the caller may not pass the string, and if we try to concatenate the non-string value with string, we may get an error. That's why first we are converting that name into a string and then we are concatenating. So this is a function definition and this is a function call. Print name Sachin, right? We are passing Sachin and this Sachin gets stored in this name, and this name's value is Sachin. Then we are saying hello Sachin, so we get this output, right? This is a call and this is the definition. So let's see the use of docstring now. So the docstring, the first string after the function header is called the docstring and it's short for documentation string, right? Although it is optional, documentation is good programming practice. Always document your code. So docstring will be written in the triple quotes so that the docstring can extend up to multiple lines, right? So now if I say print name, this is the name of the function, right? I just want to check what that function is doing. I just want to check what a particular function is doing. I can call the docstring of that, right? So print name is the name of the function dot, and that is how I can call the docstring. Right? So this will return the docstring of that function. You see, we wrote that as the docstring, right? This function prints the name. You can see that. We'll see it here. You see this, when I call docstring on this function, this line will be written, only this line will be written. Yeah, you see, this function prints the name. We name of the function dot, this doc, this will return the docstring, right? So So return statement, as we saw, it is optional, right? It is optional, and some programs they must in some programs we must write return statement. In some program we need not write the return statement. For example, right? For example, in this program like this, return statement is not required, right? Return statement, we did not write return statement here, but some programs or some functions definitely need the return statement. For example, let's say we have this function get sum, right? Def get sum. So this function get sum, to this get sum we are passing this list, right? So this get sum performs the sum of the list elements, right? And it will return the result. So this function returns the sum of all the elements in the list. So this is the docstring, right? So we are initializing this sum to 0. This sum is a variable which we initialize to 0, and we are iterating through the list, saying sum equal to sum plus number, right? So this statement we can write it like this. So this number will iterate through the list, right? So this number will assume the first value, second value, third value in the list, right? And then at the end we'll have the sum in this sum variable, and we'll return this sum variable. So let's see the call to this function. So this get sum is a call to this get sum function. We are passing this list 1 2 3 4. So this list gets stored in this lst variable, right? So lst now is 1 2 3 and 4. After this call, lst will be 1 2 3 4, and this num will iterate through this list. Num initially will be 1, so we are adding 1 to sum, right? Sum was 0, 0 plus 1 is 1, so sum becomes 1, right? Then num goes to this 2, right? Num goes to 2, right? And then we are adding again num to sum. Sum is 1, 1 plus 2 is 3, right? Likewise, we iterate through that list by using this num variable, and each time we add the number to sum, and thus we return the sum. So the sum will be written here. So this sum, this call will be replaced with the value of the sum, which in this case is 10, and then we can print this, right? Okay. So in some functions we definitely need to write the return. Some function we may need not write, right? So if we call docstring on this sum, right, like this, you will get this docstring which we wrote inside this function, right? You see, this is the docstring here. Okay. Now how the function works in Python? It's simple. We saw already, right? So we have a function here, and then we have a normal program here. As soon as we encounter the function, call, we go to the function, we execute the body of the function. After executing the body of the function, we come back to the normal program, right, at the next statement, right? So we go to the function definition, we execute that function, and we come back to the original location from where we went there, right? So scope and lifetime of the variables inside the function. So what is a scope? So scope of a variable is the portion of the program where the variable is recognized. The program in which the variable is recognized is called as scope. Now for example, you see, let's say there is a class means a school or college class, right, in which there is a person called as Sachin, right? Now scope of that person Sachin is limited to that class, let's say, right, limited to that class only. In the entire school, right, this Sachin is not so famous that the entire school knows Sachin, but definitely most of the members of the class knows Sachin. Let's say all the members of the class or that particular standard knows Sachin, right? So the scope of this Sachin is limited to that class. That means the scope of a variable is the portion of the program where the variable is recognized. Like this, Sachin's scope is limited to that class. If Sachin is a hero, let's say, or Sachin is a very famous personality, then the scope is the scope is not limited. Everyone knows Sachin, right? So that is local and global scope. We'll discuss about local and global scope, but first let's understand what is a scope. So variables defined inside the function is not visible from outside. That means when I define a variable inside a function, the variable is recognized, right, only in that function. I cannot access that variable from outside of that function, right? Hence they have local scope. Let's say I have this function here, def fung is the function. Inside this function I have this variable a, I have declared this variable a, right? So this, if I use this a here, use means access this a here like print a, right? I may not get an error. But let's say now I am out of this function, let's say I am not inside this function, I am out of this function here, right? And here if I try to say print a, right, I'll get an error. Error is a is unknown, a is not defined, a is not defined. This a was defined inside this. That means as soon as I come out of this function, I forget this a, I don't know what is a, right? So if you try to access a, you will get an error, right? Okay, so that means the scope of a was limited to this function, the block where this a is created or a is declared or defined. Okay, so that is called as a has a local scope to this function, right? But if I define a somewhere here which is not inside the function, then I can access this a from anywhere inside this program. That's why I can say that a is a global variable. A is a global variable. The scope of a is global. Right? So the lifetime of a variable is the period throughout which the variable exists in the memory. So the lifetime of the variable inside the function is as long as the function executes, right? As soon as we come out of the function, the variable is no more, right? Variables are destroyed once we return from the function. Once we come out of the function, the variables are destroyed from the memory. They are no more, right? And that's why if you try to access those, you will get an error. Okay, so let's see the scope example here. So we have this variable. This is a variable which holding this string. This is a global variable. This is the content. This is the string held inside this variable. So we have this defined test lifetime function. This is a function. This is a doc string of the function, right? And there is this local variable which is declared. Actually, local variable. This is name. By the way, this is name of the variable, right? Local var is the name of the variable, and this variable is holding. This is a local variable. If we print the local variable, you will get this output. This is a local variable. If we print the global variable, you will get the output, right? So this value, the global variable is holding this value. Now once you come out of this, right, you must call this function. See, you should call a function, then only the function gets executed. Otherwise the function does not get executed. Okay, this is a call. So this, when we call this function, these two lines will be which are in the body of the function will get executed, and we will get this, right? And then after that I have this global variable, right? So this global variable is accessible, so we get this, right? Now if I try to print this local variable, let's see what we get, right? So this is the error because of this, you see, because of this, right? Because this local variable was declared inside the function, right? This local variable was declared inside this function here. Local variable scope is only limited to this test lifetime. That means as soon as we go out of this def here we are out of this function, right? And we are trying to access this local variable from outside, right? This local variable destroyed. This variable is no more, right? It's no more in the memory, right? So we get an error. Right? That means when the variable is declared outside of any function, it is called as global variable. When the variable is declared inside a function, this becomes local variable to that particular function. Okay. So that's why we get this error. Now let's see one program which will find the HCF, highest common factor of two numbers, right? So here is this compute HCF is the name of the function. We are passing two parameters, a and b, right? So we are checking which is smaller. Smaller is b is smaller if a greater than b, else a is smaller. We are finding which is smaller, so that will help us to find the HCF, right, highest common factor, right? And then we are with this logic. We are. I'm not going to explain this logic. This is self-explanatory. You can see that, right? So with this logic, we'll get because already the video has become very long. So with this logic we can find the HCF of two numbers, right? Okay, and then we are now, this is the function. Here we are out of this function, here we are out of this function. Now with we have these two numbers, number 1 and number 2. We are passing these two numbers to this compute HCF function. This is the call to compute HCF, right? So number 1 will be stored in A, number 2 will be stored in B, right? And then this function gets executed, and this function will return the HCF. That HCF will be replacing this call, right? So this HCF will be replacing this call. Let's say in this case HCF is 6. So what we are now printing, right? So this 0, this first bracket will be replaced by number 1, the second bracket will be replaced by number 2, and the third bracket will be replaced by HCF. Thus we get this line. Okay, so that is the small introduction to function.